In this video, we're going to go over examples for the 45, 45, 90 special right triangle. One thing I need you to really understand is that there are a ton of videos on this. So if you don't like how I solve it, you can just look for other videos. A lot of people have their own different way of solving it. I'll try to give you different methods, but ultimately, right, it's whatever works for you the best. So what I want to do here in this one is just basically show you the method that I sort of like look at, and it's really just using this table here, okay? But for right now, let's really go back and let's try to understand what this is and how this relates to this little random extended ratio. So in the other video, you guys should have noticed that in order for to get a 45, 45, 90, right, we take a square and then we draw the diagonal. We obviously know that because it was a square, we know two sides are congruent. That's where the x and the x comes from. And then you guys did Pythagorean theorem to figure out what this side is of the triangle, the hypotenuse. And then afterwards, you guys figured out that there's a pattern there, right? Where you just do, oh, well, just the number with a square root 2 tacked behind it. Now, in order to basically understand this table, what I need you guys to understand is, similar triangles. Similar triangles always have the same scale factor, right? And so what that means, and because we're working with the 45, 45, 90, that means pretty much all 45, 45, 90 triangles are all similar. Just because if you have a scale factor, then you can like multiply it and it'll be the same. So that's one thing that's really nice about it. And so what that means is that let's take sort of like a base triangle that is 45, 45, 90. Like think of it as what x can be the easiest number that we can decide. And well, we could just let this square equal to 1 on all sides. So if the sides are all equal to 1, that's where these two ones are coming from, right? And then these two over here, because that's the basically like the easiest side that we can think of. And then if we use the pattern, we know that it's going to be the side length, which is 1, with the square root 2 behind it, and 1 square root 2 is just the same thing as saying square root 2. And that's where that square root 2 is coming from. Okay. And so what I'm going to do is you're either going to be using the pattern. So I'm going to call this one here like the pattern method, right? Where you just really understand what's going on with the patterns, right? You know that the two sides are congruent to each other because it's a 45, 45. And then we just tack on the square root 2 behind it. Or I'm going to be solving some of them the table way. The table way in the beginning is going to be a little bit weird, but you're going to see how just pretty straightforward it is. So I know for some of these examples, it's going to be super like easy. So just, uh, forward to the other examples that are just a little bit harder, I guess. So for right now, let me think about what's going on here. So find the length of the hypotenuse. So we're trying to figure out what that side is equal to because that's the hypotenuse. Let's see, we have a 45 angle right here just because we know how that triangles always add up to 180, and this one over here is 90, right? You can automatically assume that this one is also 45 over here just because you could do 90 plus 45 and then subtract that from 180. And so what that means is that we can go ahead and use this pattern since 3 is the length of one of the sides, right? If you really want to think about it, and this is why it's so important that you guys understand like opposite sides, that also means that this side is also equal to 3 because we're working with the x-axis. And then we can go ahead and use the pattern where you basically just get the side length and you basically you multiply a square root 2 behind it. And so then that'll be our final answer, right? Hypotenuse for this one. Wow, that's really ugly. Hypotenuse is equal to 3 square root 2. Now, for those of you guys that, yes, you can see how easy it is, but you know how to use the table. Well, the table, it's always going to be this right here, 1 square root 2. These three numbers up here on top are never going to change. It's always going to be 1 square root 2 when you are working with a 45, 45, 90 triangle. That is extremely important. Don't start mixing it because there's going to be a different table for 30, 60, 90. And so what we're going to do here is in these two blanks is where we're going to put our side lengths. Okay. And then in the last one is where we're going to put the hypotenuse. So the hypotenuse is what we don't know. Let's imagine, right? We don't know it's 3 square root 2. And then one of the side lengths is equal to 3. Notice how it doesn't matter where you put it because since it's a 45, 45, that means it's technically an isosceles, so it'll be the same thing. So you could even already like add on a 3 there. If you really want to think of it, you see how I drew the arrows in this triangle where I'm doing the what is it called, like the opposites. I'm basically going from one corner and I'm going opposite, and that's the like side length. That's how I do these basically these numbers. And so then what you're gonna do next is you're just gonna see, well, what number am I trying to solve for? I'm trying to solve for the hypotenuse. That means I obviously need to use the x. And then since these two are the same, you know, 1 over 1 through 1 over 3, 1 over 3, I can use whichever one you want, right? I'll just circle it. And so what you could go ahead and do is, this is how the table would work. We would do one fraction and then equals the other fraction. This is kind of how like scale factors work, right? You're using two numbers from different triangles and they are similar, and then you know you're basically using that. So what we can just do next, it just becomes very like what is it, like algebraic. You're just gonna cross multiply and then there you go. So it'll be, I'm gonna do this one first. I'll be x times 1 is x, and then 3 times square root 2 is just 3 square root 2, because since the 2 is a square root, we can't go ahead and give like 6 or anything. And then that's how we get this answer, which, I mean, just look at it, right? If you understand the patterns, it's pretty straightforward, okay? And that's how these first couple examples are going to be. They're going to be super straightforward. And so, I mean, you don't really have to do the table method. What I suggest you do is maybe just practice it, get into the habit of it. All right, so here goes the next one. Solve for x and y. One thing you just already, you know, notice, it's a 45, 45, 90. So we got this pattern. The 8 is one of the sides. So then that means automatically this x is also equal to 8. So that's our first answer. And so then because they gave us a side length, I can already calculate what the hypotenuse is by just using the pattern where it's 8 with the square root 2 behind it. And so then that's why with the 8 square root 2 behind it. So you see, look, that doing the pattern is extremely faster, but you know, maybe you do it so fast that you can make mistakes. So the table 1 square root 2. And so the most important one is basically the hypotenuse, because that one you can't switch it up. So the hypotenuse, you hopefully know by now, it's across the 90 degrees. So across the 90 degrees is going to be our y. And then for these two, you really, I mean, you can put whatever number you want, 8 here or x here, or the x on this one. It doesn't really matter because it's still going to be the same answer. All right, so now what's going on here in this table is, if you notice, you have two variables. So what that means is, if you want to solve it the table way, you're going to have to sort of be a little bit, you know, a little bit smart about it. You're trying to get always two fractions equal to each other, so then you can, you know, cross multiply. Okay, that's the basically key thing. Now, what you need to understand though is, in order to solve one equation, you only need one variable. Okay, so what that means is you need to be smart about which fractions you're going to use. Obviously, right, I am either going to solve for the x or the y. Let's just say I'm going to solve for x first, just because, you know, it's the first letter, whatever. What you need to understand is, well, which other fractions should I use, right? Let's just say for whatever reason you choose square root 2 over y. You're going to see right now why this is not going to work, okay? So if we go ahead and we cross multiply, I get 1 times y equals y, and then I get x times square root 2. This equation, you can never solve it based off how just it looks. Like if you're only given this equation right here in a test quiz or whatever, it's impossible to solve because you have two variables with only one equation. So what that means is that basically you can't choose these two fractions at the same time, right? You can't choose this one and this one at the same time. You have to be a little bit smart about it. So if you already have the 1 over x, you can go ahead and do the 1 over 8. And that's what's going to basically help us out. Now, if you take a look at this here, you have one equation with only one variable being x. So now I can go ahead and solve by cross multiplying. X times 1 is x, 1 times 8 is 8. And look, there you go. Okay. So like I said, the table method is a little bit, it takes a little bit longer time, but I mean, you're going to get the answer anyways. Like every time, okay? So let me go ahead, and that's the work for x. So let me do the work for y now. Now I'm trying to solve for y. Obviously need that one because I need to solve for y. What you can do is you can substitute, put the 8 there now, and now you could choose whichever fraction you want. But, you know, just in case you're not super duper sure, you could just use the information they give to you, the one that you know for sure is correct. So there you go. We can go ahead and cross multiply. Y times 1 is y. 8 times square root 2, since both of them are different, you know, the 8 is just an integer, the square root 2 is a square root, so you can't just, multiply them together. And then, we get the same answer, okay? So, like I said, it's maybe the table is super overkill for that example, but you'll get into the habit of doing them, fairly quickly. All right, so see if you can figure this one out. For those of you guys that are trying to do the pattern way, first thing you need to notice is they gave you the hypotenuse first. So you're basically given this now, and you're trying to go, in the outside direction. You're trying to go to like figure out what the leg is. For if you're thinking about the pattern, right, notice that the square root 2 is already there, just like in the pattern. And so what that means is that the x actually ends up being just 5, right? It's just like, oh, the 5 is already in front of it. So what that means is that this is 5 and this is 5, just because it's a really, really nice quick pattern. So what are the side lengths? Well, the side lengths are equal to 5, because we use the pattern. Now, for those of you guys, I would say definitely understand how the table here works, because it will give us a little bit of a not easier but more direct. It's just practicing for the table, okay? Let's just be honest. So then, hypotenuse goes here always, right? Always the hypotenuse. If you really think about it, I call this the 45, 45, 90 table. You're technically putting the side lengths in these 3 blank spots, and this is like the opposites, if you really want to think about it. So what's the opposite of the 90-degree angle? Well, the 5 square root 2. Sorry, that does not look like a 5. So it'd be 5 square root 2. What's the opposite of the 45 and the 45? Well, let's imagine that we don't know. So I can go ahead and put a question mark there. You can put X or Y if you want to. I mean, it's up to you 100%. So what I'm going to end up doing is, let me put variables, but I'm going to use the exact same variable because I know it's going to be the same answer. And so now I'm trying to solve for X. I obviously need this one. And so I already have the one variable here, X. So that means I need numbers for the other one. So then my fractions end up becoming, here, let me do it where I have space. So my fraction ends up becoming 1 over x equals 2 square root 2 over 5 square root 2. All right, so we go ahead and we can cross multiply. This is where it starts getting a little bit harder. It'll be x times square root 2. So we get x square root 2 equals 1 times 5 square root 2, which is just going to equal to 5 square root 2. Now, if you notice here, this looks like a very hard question. But if you truly understand equations, really see what's going on here. It's saying, what times square root 2 equals 5 times square root 2? I mean, the square root 2's are both there, so obviously x is equal to 5. Now, if you can't really understand that, you're trying to isolate the variable. You see that these two are being multiplied together, and so you're going to do an inverse operation of dividing by square root 2 on both sides. Think of it as like if it was x plus 2 equals 5, then you would subtract by 2 because you're doing inverse operations, right? So inverse. That's what we're doing there as well, except since it's being multiplied, we're going to divide now. Maybe a better example would have been this, right? We would divide by 2. The only difference is that this one here now is a square root 2 instead of just a regular 2, okay? But it's pretty much the same thing. And so this right here, these square root 2's, they divide to become a 1, just like these 2 divided by 2 is equal to 1, right? Since it's the same number and they're being divided by, it's equal to 1. And luckily what happens on this side is the exact same thing. So it'll be, 5 times 1, which is just equal to 5. So then that's our answer. So for this problem, the table definitely, gets a little bit more complicated, but it's really just algebra. You're just doing a ton of algebra. So we're going to get just a little bit more complicated now for these, for the rest of the problems. Okay, so if you are trying this problem using the pattern, it's actually going to be the shortcut than the table. But remember, the table is always going to work. So if you notice, look at the information that they gave to us. These are the side lengths. So they technically gave us the x already. So that means if we just use the pattern, it'll be a very quick answer. Now, remember what the pattern is. If you have the side lengths, all you're going to do is put that side length there with the square root 2 behind it. That's technically the pattern there. Now here, the side lengths is 3 square root 2. Do not confuse the square root 2 with this one here. These are not the same square root 2's, right? They're different just because of the fact that this square root 2, it wasn't given right there, right? So you need to be very careful with that. And so what we can go ahead and do is, remember what the pattern is. Take the side length, so here goes my side length, and then go ahead and tack on a square root 2 behind it. That right there now is the pattern. This square root 2 now is this one. right? Because we did the pattern. And so now what we can do is we just have to know how to simplify this entire section. So we end up getting 3 square root 2 times 3 square root 2. Since these two 2's are in square roots, I can go ahead and multiply them. And so square root of 4, it's really just simplifying if you notice what I'm doing now. Square root 4 is equal to 2 because, 2 times 2 equals 4. And so then we get our final answer to be 6. So the hypotenuse here is going to be equal to 6. I'll put a question mark just because it had a question mark right there. So this one here, if you notice, the pattern was a little bit harder, but we ended up still doing what we knew we had to, which was, tack on a square root 2 right behind it. For the table now, this would be really, really interesting to see how it's gonna look pretty similar. You're gonna notice. So my sides are let's see, 3 square root 2, 3 square root 2, and then my hypotenuse is what I don't know, so I'll put an x there, just because, okay. And so I'm trying to solve for x. So let me go ahead and we'll do this one, obviously, because I'm trying to solve for x, which is the hypotenuse. And you can choose whichever one you want to. It doesn't really matter. So then this is going to be my setup. It'll be 3 square root 2 equals square root 2 over x. The next step is to go ahead and cross multiply. And this is the reason why I chose red right now. X times 1 is x. And then it'll be, sorry, that's super long. And then it'll be equals to the other cross multiplication, which is 3 square root 2 square root 2. Which, if you notice, there we go. It's the exact same steps now. So I'm not going to write them again because you already have them. Okay. So just what the table really does, if you really want to think about it, it sort of just simplifies it. It kind of like strips away the pattern a little bit just so it could be like super algebra. You just have to know how to fill the table in correctly. So same exact thing as the other one. Go ahead, give it a try, pause the video and see if you can do it. For those of you guys that are doing this in the pattern way, notice that they gave us the side length. So again, it's really just going to be tacking on the square root 2 in front of the side length that they gave us, which was 5 square root 6. So it'll be 5 square root 6. There goes my technically x, right? And then it's put a square root 2 right behind it. So I technically end up getting 5 square root 6 square root 2, which I know it's 5 square root 12. You're going to need to be able to recognize when you can break down these square roots. So let's see, a 12, you can break it down by saying 3 times 4. You can say 2 times 6, 1 times 12. We look for the biggest perfect square root for 1. I think that's it. Yeah, so then that means you are able to break it down 3 and 4. So we end up going ahead and doing 5 square root 3 square root 4. Okay, and then it'll be 5 square root 3. This now becomes a 2. So we could bring that to the front because now if you notice, the 2 and the 5 are both just whole numbers outside the square root. So it'll be 10 square root 3 because we are technically multiplying. So then the h here is technically equal to 10 square root 3. So, I mean, if you by yourself got to this part here, you're pretty much like done already with the special right triangle work. The rest of the work is just, I'm not gonna say basic math, but just knowing how to break down a square root. Okay, so don't get bogged down on that. If you're able to get to the 5 square root 12, that is a great already. Like you're like 80% there, right? The 20% is just being able to do this part here, which is, it's just like algebra really. All right, now let's go for those of you that tried the table. 1 square root 2. It'll be 5 square root 6, 5 square root 6. And then they used h, so I'll use h as well. And we choose 2 of them. So it'll be 1 over 5 square root 6 equals square root 2 over h. Now I can go ahead and cross multiply. H times 1 is h. And then we end up 5 square root 6 square root 2, which again, boom, we already did that work there. So for those of you that did it the table way, all you had to do now is just take it from here now and just follow the work because it's pretty much the same thing. Okay, so my answer is going to be, final answer, it'll be 10 square root 3. And we get it the both different ways. All right, so let's go ahead, pause the video, see if you can do this one. for those of you guys trying it the pattern way, notice how they gave us the hypotenuse now and not the side length. So this is going to be a tad bit different than the ones we've done so far. So if they gave us the hypotenuse, that means that I need to think about how to break down the hypotenuse where I can see what the x value is. The really nice thing is that it is a square root 2. So if you really want to break it down, it's technically like saying that right there. Right? The square root 2 is the pattern one, and then this 2 in the front ends up being like our x. So that means we could go ahead and put a 2 there. Okay. And so then there you go. That's it, right? People that want to do it the pattern way, 1 square root 2. Now I know this is like a super like repetitive, but just think about that. The reason why it's super repetitive is because the 45, 45, 90 is just always 1 square root 2. So then, oh wait, I erased it and I put y literally again. It should have been xx because you know it's these two should be congruent, because if this one is 45, then you're using basic math, knowing that a triangle adds up to 180, blah, blah, blah. So then, you know, cross multiply, we end up getting, oops, sorry, no, setting up our equation, we get 2 square root 2. So there's two different ways of setting this up a little bit. Some of you will probably want to do this and say that's equal to 1, and it's true, but notice where the 2 is. So it's technically going to become 1 over 2, okay? This 2 is in the denominator, it needs to stay in the denominator. So you could do that there, right? And so then when you cross multiply, it'll actually be with the 1 instead of the 2, because you already, you know, simplified. So it'll be x times 1 is x, and then it'll be 1 times 2, which is 2. Now, if you don't like that at all, which, let's be honest, I think some of you guys won't, let me show you the way where you would just like, you know, just cross multiply from the beginning and just see what you get. You would get x times square root 2. So let me put that over here. So it'd be x square root 2 equals 2 square root 2 times 1, which is just 2 square root 2. And we basically end back to the problem we had done before already, right? Where these two are being multiplied, and so I need to isolate the variable. So I would divide by square root 2. Luckily, this cancels into a 1. This cancels into a 1. And so, boom, we have our answer. All right, so there you go. This problem, really easy. I just want you to think about this right here. If this problem had it as 2 square root 2, imagine just how much harder, instead of a, let me do this, 45, 90, instead of it being a 2 in there, if I put a 3. Now this problem, this one right here, is way harder because you can't separate it like this. Remember, the pattern has to have a square root 2 there. If it doesn't, then you can't do the pattern really quickly where you separate it into x and the square root 2. So for those of you that want a little challenge, and definitely you're going to have to be able to do problems like this one, give this a try and see what you end up getting. Okay, so let's go ahead with the next example, and it's going to get a little bit more complicated now. Pause the video and see if you can figure this out. So for this problem, if you were trying to do it the pattern way, it kind of breaks down right there because of the 26. There is, if it would have been a, let's say for instance, the problem was 26 square root 2 right there instead of 26, then super easy, right? These two, 26, and then boom, you're done. But it's not, okay? So that's why this problem becomes a little bit harder. It does have a sort of like a shortcut pattern method, but I'm going to explain that one after I do the table, because I personally feel like the table is a little bit easier. They're basically the same way, let's just be honest. So let me just jump into the table way. 1 square root 2. And then I can go ahead, 26 is the hypotenuse because it's across the 90-degree angle, and then F and E. If you notice the two little tick marks, so what that means is they're basically the same exact thing. So F is equal to E, okay? Keep that in mind. So what I'm just going to do is I'll solve for, I don't know, whatever, F, okay? So my equation is going to be 1 over F is equal to square root 2 over 26. I can go ahead now and cross multiply. It'll be F square root 2 times equals to 1 times 26. So right there, now we end up with this problem here where you're going to have to isolate the variable, which is F. If you only look at this left-hand side, again, notice it's a F square root 2. These two are being multiplied. And so to do inverse operations, we divide by square root 2. Now, for those of you that at least got to this point, I really hope that you understand why this problem becomes now a little bit harder. So it becomes 26 square root 2. Now, I really want to say that even though this is the like completely correct, looking at a lot of like college classes, textbooks, that won't be the final answer. You have to do this thing, or from what I remember, you have to do this thing called rationalizing. Okay, so let me write that down if you want to like Google it or something. Ration. I have no idea if I spell rationalizing. I think that's how I spell it. No idea. Right? So, and it's a fairly sort of easy thing to do. So, rationalizing is basically it's something that you need to do whenever you have a square root in the denominator. You kind of don't want square roots in the denominator. So, what you would do is you would multiply whatever this number is. So, for in this case, it's a 2. So, you would multiply by square root 2 over square root 2. Both the numerator and the denominator, and then what ends up happening is that the denominator ends up basically simplifying, right? Because you force it to become like a perfect square root by multiplying by the same number. So say for instance this denominator, instead if it would have been a square root 3, then the sort of, I call it a I forget what I call it in class. I call it like a random step. That's what I call it. I call it the random step. So you would have to do this random step only when the denominator has a square root in there. That's the only time you would have to do this random step here. So let me go ahead and clear up some space here. So what I'm going to do is I'm going to rationalize this fraction here. So 26 square root 2. Since the square root 2 is in the denominator, I'm going to go ahead and multiply by square root 2 over square root 2. If you notice this fraction there, it's technically equal to 1. So you're really just multiplying by 1. And so we end up getting 26 square root 2 over square root 4. And then we know square root 4 is equal to a 2. So it would be 26 square root 2 over 2. Technically, if you're doing the rationalizing step, this should always happen. You should always get a perfect square root in the denominator. You know, square root 4, square root 9, square root 16. It should always be a perfect square root. And so then we can keep going. Now look at this here. We can technically divide these two numbers because both of them are outside the square root. And so we do 26 divided by 2, which is 13. Oops, sorry about that. That's over 3. And then square root 2. Notice that when you divide these two numbers, the 26 is the bigger number, so that means it'll be like a numerator answer. If it would have been like this, sorry, that's a 26, then that means it would have been square root 2 over 13. Okay, so it's really important where the greater number is at. All right, so then we end up right here, and unfortunately, I would say that this here now is the final answer, 13 square root 2, which is the exact same thing as 26 square root 2 because that's what we started with, but the final answer is technically 13 square root 2. Now, of course, there's always patterns, okay? I need you to understand that. Now, after I do the next example, hopefully you can see what the pattern is, but there you go. Now, for those of you that are saying, or for those of you that are thinking, all right, cool, oh wait, I'm sorry, I forgot to say one last thing. F is equal to square root and then also E, okay? Don't forget that because it was technically asking for 2 answers right there. But whatever. All right, so for those of you guys asking for the shortcut to this, let me redraw the triangle. Let me just pay attention to how it looks, which I already forgot, I'm not going to lie. So it's going to look something like this. Let me do a straight line here. And then the 26 is here. We got tick marks, and 90. All right, so now this is obviously a 45, 45, 90 special right triangle. For those of you guys that don't remember it, you know the pattern ends up looking like x square root 2. So what that really means is this right here. You're trying to get this basically to somehow become that there. Like if you can somehow get a square root 2 in there, or you can get it to cancel out or something like that, then it'll be actually really, really nice. So really think about it like this here, okay? Imagine that you're working with this x value and you're trying to go here. So you're saying, what times square root 2 is going to give me 26? That's what you're really thinking about. Like, what times square root 2 gives you 26? And so what you can do here is you can just obviously, you know, divide by square root 2 and then boom, you're there at the rationalizing step. Right? So really just think about that. Divided by square root 2. Because you're trying to figure out what that what is. So then it'll be 26 over square root 2. And so there you go, right? That's the, I mean, sort of shortcut method, but I mean, not really, because you're still going to have to go ahead and rationalize and whatever. But that's what you're really kind of trying to do there, like in a very shortcut kind of way. But I mean, honestly, for me, I wouldn't really like sort of like waste my time with that one a little bit. I would just do the table because it just, for me at least, it just makes way more sense, than anything else. So let's go ahead with a very similar problem. See if you can do this by yourself. If you notice the shortcut, just do the work and see if you can, get to your shortcut. But yeah, so there you go. So what is the value of x? All right, 1 square root 2, and then we end up getting 6 there because that is the hypotenuse. X, I mean, I don't have another one, but you know that those two are congruent, so I can just put x there. Set up my equation. It'll be 1 over x equals square root 2 over 6. That looks really bad. Let's go ahead and we can cross multiply. You really need to get used to rationalizing because it will happen with the 30, 60, 90, and then, it could potentially happen also to this one. Or a lot more frequently. So it'd be x square root 2 equals 6. Sorry, I did that line first. I don't know why. And I can just divide by square root 2 because I am trying to isolate the variable. It'll be x equals 6 square root 2. For those of you guys that are, following and stuff, this is where you need to do that random trick. Yeah, that's what I call it in class. I call it a random trick. I'm not going to lie, there's a lot of these, especially if you guys move on to like higher level math. They're just super random, but you're really just trying to understand what's going on, right? You're trying to get this denominator to become just a regular integer. The way to do that is by forcing it to become a perfect square root, but you can't just, randomly say, hey, like I'm going to change this 2 into a 4, right? You can't just randomly do that. You have to do, like a still valid math, which technically here you're multiplying by 1. So you're not even changing what the fraction is. You're just changing how it looks. So it'd be 6 square root 2 over square root 4. And then let me just give myself more space. And then that'll equal to, what is that? 6 square root 2 over 2, which is equal to 3 square root 2. So then that right there is equal to x. So x is equal to 3 square root 2. Some of you guys are super smart, super, smart, lazy, or lazy smart, however you want to call it. You guys already noticed the pattern. I'm not going to say it out loud, but there you go. Now, to throw you off even more, look at this. I totally wrote this because I noticed there was no examples for this one. But here you go. So solve for x and y. First of all, there's not even any x and y, so my bad. So there you go. All right, so this is a super, challenging problem. You have to know how to do this. So give it a try, okay? See what you get. I will do the work, so, you can see if you're right or wrong. All right, so definitely not doing this the shortcut way. I'm going to do this the table way. So 1 square root 2. It's solving for x and y, but we know that these two are equal to each other, so I only need to solve for one of them, okay? So xy square root 7, because square root 7 is considered to be the hypotenuse, okay? So now I'm going to go ahead and choose 2 of them. I just circled y just because it's there. Honestly, it doesn't really matter. So let me make a line here so I won't get confused. So to be 1 over y is equal to square root 2 over square root 7. And now let's go ahead and let's cross multiply. It'll become y square root 2 equals 1 times 7. Sorry, square root 7. Now I'm going to go ahead and divide by square root 2. Notice these steps, very, very similar. So it'd be square root 7 over square root 2. Now, one quick thing I need you to understand. Do you need to rationalize here? The only thing you look at is the denominator. Don't even care what the numerator is. Is the denominator square root? Yes, okay. Is it a perfect square root? No. Boom. You got to rationalize. You got to make it into a perfect square root. So let's go ahead and do the random trick here, okay? So that means I need to rationalize. So times square root, that's supposed to be a times. It's 2 over square root 2. And so now this is where, go with your gut instincts. Think about what you're doing. 7 times 2 is 14, so I can do that. And then I end up getting square root 14 over 2, okay? Because square root 4 is 2. Now 14, can I break that down? So it's 2 times 7, 1 times 14, and that's about it. The greatest square root is the 1, and that literally does nothing. So what that means is that this is my final answer. Now, definitely for that one, Yeah, no. I know the little trick that you guys saw there in the previous two problems kind of like breaks down a little bit here. Not really, but I'm not going to really go into that, okay? So there you go. All right, so this one, the answer is square root 14 over 2. So let me write that down so we can have it. X is equal to y is equal to square root 14 over 2. So definitely these problems can get a little bit harder, just basically on the stuff I give you. Like for instance, if I give you the hypotenuse and it's not the pretty pattern, then you're gonna have to do work. There's really no way around it. Okay, I know rationalizing kind of sucks, but if you really think about it, it's super straightforward. You're just gonna multiply by whatever the denominator square root is, top and bottom. For the 45, 45, 90, it's pretty much square root 2 all the way every single time, because that's how the table works. But when you get to the 30, 60, 90, that's where it gets a little bit harder. Okay.